Okay, that was for the beginning of the semester. And from now, we're going to think about instructional strategies that we can use during the course. How to retain students who has different levels of experiences and backgrounds and can keep engaging them in the programming courses. Novice learners need step-by-step guidance that are aligned with their learning progress. When you're having diverse students who have different background knowledge levels or experiences in programming, it is hard for you to fit your instruction into each one of them. However, if you are presenting the course topics with partially completed examples or showing the programming process with think aloud strategies, students will be able to follow the problem-solving process. Also, by dividing the problem-solving process, it is easier for you and also for students to figure out which part is still unclear for students or need more demonstration. In the next slide, we're going to think about cognitive load theory that explains why it is critical to provide step-by-step instruction. What is happening in your brain when receiving new information? When new information is coming, our information processing system in your brain is working. Dr. John Streller found that there are 3 different types of cognitive load to process the new information. He found that the load on that memory is split into 3 uses. He calls it germane load, intrinsic load, and extraneous load. Let's take a look at next slide. Let's look at this numerical formula. What do you have in your thoughts? Probably you think of 10, right? I think you try to 7 plus 3, that's 10. But if kids who just learned how to read numbers and operator will do math, this is math, and this is about plus, and there are 3 and number 7. And let's think about another younger kids who have never learned numbers or operator. They may see angular line and crossing lines and stacked curved lines. So depending on the cognitive development, individual has different levels of information processing routines. The routine to process sensation into information is called as schema, or schemata in plural. Depending on individuals' available schemata, each individual needs different cognitive load is imposed to process a task. You and me also already know how to read numbers, even how to sum 2 numbers, and that led us to think number 10 automatically when I showed you 7 plus 3. Because you have schemata to sum 2 numbers. But think about preschool kids or first graders who have not built the schemata to sum 2 numbers. They may need more time and effort, which means need more cognitive load to sum 2 numbers. This is what we call intrinsic load. For example, like speaking of your students in computing courses, if they already took at least 1 computing courses, they have built basic schemata on programming. So they may need less intrinsic load compared to who are never taken any programming courses. Other than intrinsic load, what other cognitive loads are imposed while learning? We hope every single student in our class is highly focused on the class and never be distracted even a second. That's our hope. Again, it's hope. However, we're all human. We are easily distracted. Even us. Let's think about you. You may think of, oh, I'm so hungry, or oh, I'm so sleepy. Or you just may think, Eunice's accent is so odd, and so on. And those destructive thoughts are what we call extraneous cognitive load. So, to maximize students' learning gains during your course, the instructor needs to minimize to provide your students with any chances to provoke distractions. Here is a simple example. Look at this. When presenting 7 plus 3, what if someone posed the numbers like this? Let's say, just for fun. Instead of encouraging students to calculate, students may think tons of different distracted thoughts. Green and red. That's Christmas colors. Oh, Christmas. Like this, unnecessary information or images distracted students as it increases extraneous load. Rather, your instruction should focus on supporting having germane load, the learning part of your brain to build new schemata. What we need to encourage students to build is creating new cognitive processing routine. For example, in the programming courses, to create information processing routines for coding, as we automatically calculate 7 plus 3. That's what instructors need to focus to grow the germane load. So, in summary, cognitive load theory helps us to know how to teach more effectively. In any ways to process information, 3 different types of cognitive load are imposed. Since extraneous load is distraction, it should be minimized. Intrinsic load is routine to process the information, so it should be managed while learning. And the germane load, learning is to create new schemata, new cognitive strategies, problem-solving skills by maximizing using germane cognitive load. So when teaching, keep the cognitive load theory in mind, considering 3 different types of cognitive loads that are posed when learning new information. Begin with considering students' prior knowledge levels. From there, present new information and use strategies step by step to let students build new cognitive process routines with germane cognitive load. And to maximize germane load, try not to impose any distracted information that would increase extraneous cognitive load. So far, we talked about how to motivate and engage students in your classrooms. Especially when you're having students from diverse backgrounds, diverse prior knowledge levels, or experiences in computing. From next video, we're going to talk more about the specific strategies that you can use to scaffold students' learning during the course.